We are happy to have you here today to share with you part of our AWS security story. My name is Sharif Talat. I'm working as a Senior Solutions Architect for AWS, and in today's presentation, I will be talking to you about how we can use encryption in AWS for a better data protection. Dance like no one is watching, encrypt like everyone is. A very popular quote by our CTO, Dr. Werner Vogels. It may sound like a very simple statement, however, it has a very bigger impact on our data and organizations today. We may argue about what are really the main driver behind using encryption. We can say regulation, compliance, or maybe just having an extra security layer. But in fact, we are all sharing the same end goal, which is basically minimizing unauthorized access to our data. This data could be anywhere and everywhere. It could be traveling over the wire, what we are referring to as data in transport or data in transit, and usually for this we use something like TLS, IPsec, and MACsec encryption with keys or encryption keys under our control. We can also look at the data at rest, so data being stored in form of file or in a folder or any form of storage. It could be network storage, local storage, or even flash drive. And the last part, which is data being in use, like a data being processed in the memory or even the source code of our application. Of course, we shouldn't store any or embed any clear text sensitive information like password, secret, tokens, and so on. You will notice here that I mentioned keys under your control multiple times because encryption is all about having a secret key to your data, and you and your organization should be the only ones eligible and allowed to edit this key, use it, and update it, and whenever needed, delete it. We have a look at AWS cryptography stack. We nearly employ AWS encryption across all of our layers, from a physical layer to data layer to network layer, represented by AWS services like VPC, VPC peering, and VPN. We can also have it on the transport layer, your front door to the internet, something like load balancers, CloudFront, and API gateway, and even on the application layer, from a client-side perspective and server-side perspective. So now let's have a look on what option we have in terms of data in transit security. So we have multiple options based on what services you are using in AWS. So encryption is started by Amazon VPC. So all the communication between the instance or EC2 instances running on your VPC is encrypted. Also, if you are using the VPN or AWS VPN or even a third-party appliance from our supported vendor on the marketplace, we employ encrypted tunneling and encryption between Amazon VPC and any remote network. The other option as well is for, as we mentioned earlier, the front doors. You have in front of your application, you have an application elastic load balancers, whether it's a network or application. You have Amazon CloudFront as a content delivery network or Amazon API gateway. Even if you have an application running on top of Amazon EC2 instance, you can import or bring your own TLS certificate to use it over HTTP. In AWS, in that front, we have AWS Certificate Manager. And AWS Certificate Manager is basically a service, a managed service that can help you to quickly and easily create, manage, and even deploy certificates, TLS certificates on AWS services. It also supports public certificates, and also recently we announced support for building a private certificate authority. The main idea here is to help you with the undifferentiated heavy lifting of dealing with the certificate renewal, and because of the direct integration with AWS cloud services, we can deploy this on behalf of you as well. We also, instead, we are talking about the data in transit, and we also have AWS S2N, and S2N is our own implementation for TLS to provide you with a better performance and faster performance on the security of the transport layer. We use this mainly in many of our AWS services, and we can take S3 as an example, Amazon S3, all the encryption of the S3 employing S2N. A very important note here, S2N is an open source project. It's available on GitHub, and you can go and download it and start contributing to the source code and use it even in your application. So now I'll switch gears from data in transit to data at rest. And when we're talking about data at rest, we're mainly talking about two main things here. We're talking about the client-side encryption. And in this situation, you encrypt your data before sending back to AWS or submitting your data to AWS. You can have your own encryption keys or maybe use a keys provided by another key provider like AWS KMS, Key Management Services. You can also use tools like AWS Encryption SDK and Amazon S3 Encryption Client and DynamoDB Encryption Client. The other type, of course, server-side encryption, and in this situation, AWS will encrypt the data for you on behalf of you as soon as the data submitted or stored on AWS. You can use, again, AWS Key Management Services as a backend for managing or as a service to fully control the life cycle of the keys, including the permission. It's very important also to highlight what the capability of Amazon or AWS Encryption SDK. We are trying to make it easy for the developers to use encryption in their application. Usually as a developer building an application and want to employ encryption, I have to answer many questions. Maybe I don't have the right information, maybe I'm not aware of the compliance requirement for my customers, because it's a very long list. So I have to answer questions like, which algorithm should I use for the encryption? Which mode I needed for this algorithm? How I can generate the encryption key, how to protect it, where to store it, and even how my users or end user will be able to use this. With Encryption SDK, what we are trying to make it easy here is just as a developer, you have to focus on main two things. The first thing is the object or the data stream or a file, whatever object you want really to encrypt. And also you have an identifier or a reference for a pointer that refers to your identity or cryptographic key provider, like for example, AWS KMS. And then accordingly, KMS will be taking care of the key generation, key protection, and even all the characteristics of the key, like which protocol, in which mode, and which algorithm, and so on. The encryption SDK is available today in different programming languages, including C, Java, JavaScript, Python, and CLI. So far we talked about data in transit security and the option for data at rest. In multiple occasions, we mentioned AWS KMS. So what is really KMS? So KMS, it's a key management services, is a managed service again from AWS that makes it easy for you to create, control, and manage the keys used for the cryptographic operation. All the high availability, storage, security, and even auditing for that key management services is part of the service. You can also have full integration with identity and access management for a full control on the permissions. We can also have a full integration with CloudTrail to make sure that you have a full logging for all the activities for the API calls for the KMS. It supports symmetric and asymmetric encryption, and most importantly here is a direct integration with different many AWS services across different categories, from a compute, storage, database, and even enterprise application like workmail and workspaces. Part of KMS, what we have it here as part of the server-side encryption, the hierarchy or the key hierarchy for KMS. So initially we have what we call the green key, which is the data key. This is a symmetric key. We use it to encrypt the data. And then that data key, we encrypt it with a higher grade key called customer master key, the one in red. And this hierarchy helps us with employing and using envelope encryption. And there are many benefits for using envelope encryption. The first one is you limit the risk of compromising a data key. We don't store plain text data key anywhere. We just store encrypted keys. The second one is the better performance for encrypting large data. Usually what happens when you're using a symmetric key, because it's faster, you use symmetric key, but again, it's not secure enough, so you have to do multiple iteration of encryption. So rather than encrypting a large volume of data multiple times, we just encrypt it the first time, and later on the key itself, we just encrypt the key in multiple times using multiple keys. It also makes it easy to manage a smaller number of customer master key rather than dealing with billions and millions of data key from a management perspective and even from audit perspective. So let's take an example of an envelope encryption for one of the services. So we have here Amazon S3. It was enabled, you have S3 bucket, enabled with server-side encryption. So we have the key hierarchy we mentioned earlier. And you are trying to upload a file. What will happen? S3 will take that file and try to encrypt it. The first thing, it will talk to KMS asking for generating a data key. KMS will reply back with two versions of the data key, one plain text and one encrypted. The plain text will be used for encryption, the original file or the original content, and the encrypted text or encrypted key will be stored with that object on S3. Notice here, we don't store the plain text key anywhere. Later on, the next day, you are trying to open that encrypted file. Because S3 doesn't have a plain text key, but the encrypted version, will send it back to KMS, asking KMS to decrypt it, and accordingly, using the customer master key or the respective master key, will decrypt the data key, send it back to S3 to use it to decrypt the file. A main advantage of, as I mentioned earlier, for the envelope encryption is the higher protection for the data keys and combining the strengths of multiple algorithms. Symmetric key algorithm for faster and producing smaller ciphertext, and public key for securing or better securing the data key. Now let's put this into architecture. What's happening under the hood with KMS? So we just, in the previous example, we have seen we are sending data between S3, asking KMS to reply with the keys or data keys. In that situation, you can send, from an architecture perspective, you can send your key either or your data through client encryption using Amazon SDK, AWS Encryption SDK, or through any of other services. In both cases, all the requests will go to a KMS API endpoint, which is responsible for doing an authentication, authorization, and logging for all the actions. And based on the requested API call, automatically KMS will talk to the backend HSM to do this requested cryptographic operation with their data key generation, encryption, and decryption. So the keys resides on the HSM, and in some cases you want to have a backup of that key outside the cloud, so you can use your own premises to create the key and import it to the HSM. This is what usually referred to as bring your own key. You can also, if you want to have more control on the store location where we store the keys, we can use a custom key store to refer. Instead of using a KMS HSM, we can replace it with AWS CloudHSM. You also have a full control on the key. We have a resource policy. It's a JSON document that you can use it for any key policy you have, and basically to define who would be the administrator and who will have the access, which entity can have an access for the key, to use the key. As you see here's the example, I defined this key can be only used by Redshift services in a specific account hosted in a specific region. As we mentioned earlier, it integrates fully with identity and access management. Now we'll go through a quick walkthrough demo to understand the process of creating a key. So of course you need to log in first to the AWS console, search for KMS, and create a key. So the first step here is you have to decide the type of the key. Is it symmetric or asymmetric? And if it's asymmetric, you have to decide the purpose as well. Is it for encryption and decryption purposes or for signing and verification, like digital signing? Then you choose your key specifications, like which algorithm, and then your key material or your key store, where you find the key, from an on-premises HSM, native HSM, or cloud HSM. Once you do this, you provide a name or an alias for the key. We defined one Mia security roadshow. You give it a description, and maybe you can assign a tag for resource tracking and cost tracking. Then you assign a permission, who will be the administrator for this key, and you define the usage permission, who will be eligible to use the key for which operation. As we mentioned, it integrates fully with identity and access management, and you can even assign resources from another AWS or principals from other AWS accounts. As soon as you create the last step, you will see a policy you just created for the permissions. You review it. As soon as you are happy, you press finish, and it will be available, the key will be available for all the integrated KMS services on AWS to use. So for example, I'm trying to encrypt an EBS volume, and I can see here the key I just created. Another example, I'm trying to create a new database, and I still see the option for using MIA security roadshow key. I created part of my demo to encrypt the database. So we have seen how easy and how straightforward to create a key. So what else KMS can do it for me? So KMS can really help you can serve you as an extra assurance layer from an operation perspective. So think of what would happen if someone by mistake changes the configuration of an S3 bucket from a private to cloud, or took a snapshot of an EBS volume and made it public instead of private. Such assurance with KMS can be provided by KMS, and the idea here, even if I manage to get access to the physical files, as long as I don't have access, my name is not on the approved list for KMS, I will never be able to access the file. A very important thing here, we cannot export the customer master key from KMS, which means the keys are secure there, and even if I got the file, I cannot take the keys. It can also help you to prove to you and to the management who has access and who doesn't have access to the content. Apart from the operation excellence, it can help you also with the audit. So the first option, of course, we are using something we call it encryption context. This is a feature of AWS KMS, and encryption context is an additional kind of authenticated data to enable you with what we call it authenticated encryption. Think of the multi-factor authentication. It's something you know and something you have. Putting this in the context of KMS encryption context, something you have is a permission or access to use the key, and something you know is the encryption context. Encryption context could be any value or anything that is not sensitive. Make sure it's not sensitive because it will appear in the log. It could be something like resource name, project name, application ID, whatever you like. It can help you later on with correlating the logs in the CloudTrail. It can also help you with proving the access and prove non-repudiation. One important thing here, if you fail to provide the same encryption context that you provided during the encryption process, the decryption process will fail. Again, this is an extra authentication layer. You can also integrate KMS with AWS config to track all the changes that happens on the key from a policy, from an attribute and configuration. This will really help you with staying in compliance with the organization standard policy. And recently we have announced an integration with AWS Security Hub. As part of foundational AWS security best practices standard, we are looking at the key configuration to make sure it's configured according to AWS security best practice. Here is an example of the KMS usage key usage with CloudTrail. What will appear to you when you look at the KMS logs in CloudTrail? This is just part of the information. You can see an example of the full list of the information in the link mentioned below on the slide. But the bottom line here, you can get lots of information, right? So you can get the event, which API we called the decryption API, at what time, which key we refer to, from which IP address, what's the source IP address, and even what from the encryption context, which application or resource requested this operation by which user or for which user. And we can put this into a bigger solution, like a complete auditing solution using AWS services. So simply, as we mentioned, we have many AWS services that can integrate with KMS, and KMS, of course, writing logs. The logs will be sent to a CloudWatch, and accordingly, CloudWatch event can trigger Lambda function. That Lambda function could be as simple as just extracting the information and storing it on S3. Later on, you can use something like Amazon Athena to query this information, and Amazon QuickSight to visualize it. And think of this, some examples of the reports or queries you can build is as simple as showing all the users of a specific key, or all the action by a specific user or a specific service, or even some particular event like a key is scheduled for deletion or rotation. This can be beneficial for teams working in incident handling or threat hunting. We're still talking about KMS, But one of the things that we mentioned as part of talking about KMS architecture is that you can find, maybe you have a regulation that mandates an extra assurance or extra control on the key store. A key store is a location where you store your cryptographic keys. However, usually when we're talking about key store with more control, we're talking about HSM, hardware security module. Hardware security module is very expensive technology to have. Not because of the cost of the hardware itself, but all the attributes and the items around it, from a data center equipment, from a maintenance, from dealing with that. And also you have, because it holds the most precious thing, the keys to the kingdom, you have to have at least 2 HSMs for a backup. So you double the effort. So what we're doing with CloudHSM, you take off this undifferentiated heavy lifting of your shoulders from high availability, from hardware provisioning and maintenance tasks and backup, and you just focus on the important things, the application integration and managing the user access to those keys. In AWS, we have AWS CloudHSM, a fully managed service that automates those time-consuming administrative tasks for you, such as hardware provisioning, software batching, high availability, and even backup. It can even scale quickly on demand to accommodate any load with no upfront cost. It's worth mentioning it's backed by a FIPS Level 3 validated HSM. It's a single environment just available in your virtual private cloud, your Amazon VPC. It also supports the integration with other commercial HSM solutions in the market to make it easy for you to migrate your keys on or off AWS whenever you want. We take care of the undifferentiated heavy lifting in terms of the infrastructure. However, you are still, because you need more control, you are still in control of the configuration management, the compliance activities, monitoring the performance, and even scaling whenever needed. So now with KMS, putting this in the context of KMS, you want to get the flexibility of KMS with all the logging and the authentication authorization capability, integration with other AWS services, but in the same time you want more control. And this is something that we can give to you as part of KMS Custom Key Store. What we are doing simply is you have CloudHSM fully under your control. You store all your cryptographic keys in that CloudHSM and get the benefit of using KMS endpoint as your front door to allow the interaction with other services like AWS services, or even third-party application you are building or custom application you are building through the AWS Encryption SDK. Here is also an example, as we mentioned multiple times, that we can integrate with multiple AWS services. Here's part of the list of the services that can integrate today directly with AWS KMS. Of course, this list is getting bigger month over month, so you can always refer to the link at the bottom of the slide to get the most updated list of the integrated services. Also, if you want to read more about the details, what's happening under the hood for KMS, what are the best practices for deploying KMS, and even the compliance report from our third-party auditors, you can check the resources on the screen. With this, I reach out to the last slide of my presentation. It was an opportunity. It was a pleasure talking to you today. Thank you.